Hi everyone. We're going to follow a similar pattern with rational functions. We're going to start with a review of some of the algebra of rational functions and also a little step up just in the difficulty and messiness of the algebra that we do. And then we'll review the function notation parts and really focus on some of the stuff that you're going to see in calculus. And then we'll spend a little more time looking at the graphs of rational functions and figuring out how we can put together a decent rough sketch from the equations. And we'll focus again on the factorable rational functions when we're graphing. We don't expect to be able to graph every single rational function, but we should be able to do a decent job by the time we're done with this. So the first thing that I want to look at is just what does it mean to simplify a rational function? And this is the easiest piece. So I'm going to jump right in with some examples that look a little more like what comes up in calculus. So I even said it here. What it means to simplify is to reduce the fraction if possible. So we're going to look for a common factor top and bottom that we can cancel out. And looking at this first one, the top is split into two terms, and this is really important that we're looking for this difference between terms and factors. Anything attached by multiplication is a factor, and anything attached by addition subtraction is a term. So this is two terms, and within each term, there are some factors and some terms. There's more than one of these things happening, but the big operation is that subtraction in the middle. So while I'm looking at each of those terms that I just put brackets around, I'm saying, okay, what could I factor out? What do they both have? They both have a 4. They both have some x's. The first one has an x cubed, the second one has an x squared. So we can take out 2 of those, right, an x squared. And then the 4x plus 6, 5x plus 2, those don't match. We did practice factoring out something that looks like that. So watch for that. I think that's always ideal. If you could factor out that bigger chunk, do it. But here it looks like we're only going to get a 4 and some x's. So I remove, and in fact, you know what? I'm going to take the minus sign as well. You don't have to. That's up to you. Just be careful either way about the signs that you're left with. So if I take a negative 4x squared out, what's going to be left is a positive x and a 5x plus 2 from this first bracket. So one of those x's and the 5x plus 2. From the second one, I'm dividing by negative 4x squared. So everything out in front is going to be removed. So it's going to turn into a plus. Dividing negative by negative becomes positive. And all that's left is the 4x plus 6. I put those parentheses there just to be really careful, but the second set I don't end up needing. It's not attached to any multiplication or exponents or anything like that. So I can actually drop that second set of parentheses at any point. The first set will matter. I can see that I can distribute through. There is an x attached, so we do want to be careful with that one. I can actually do my main goal right now. I can cancel out a 2, top and bottom, and I can fully cancel out that x squared. So I'm actually going to end up with something that's not a fraction. So I'll have a negative 2, and then in the parentheses I see a 5x squared plus 2x plus 4x plus 6. And remember, canceling is a division. So when we divide and everything cancels out, we're left with a 1. So this is all over 1 now, which means we don't need to write it. You could distribute the 2 in if you want to. I don't really care either way. Since our goal is factor and cancel, I would say don't bother distributing it back in. That's extra work. But if you feel like doing it, it's completely acceptable. The only thing I do want to complete is combine like terms in the middle. The 2x and the 4x can be added up. So there is my reduced fraction. It's not even a fraction anymore. Okay, and I want to do one more, and this also, both of these look very much like something we'd run into in calculus. You'll be doing this exact sort of algebra. Our goal is still to reduce. Right now, the only thing in the denominator is an h, and this is going to be a very typical thing you do right at the beginning of calculus. You'll set up difference quotients, and they'll look something like this, and your goal will be to cancel that h out. So I don't have anything I can factor out of the top this time. The 9 plus h is really tempting, but that minus 144 at the end isn't looking so great. Actually, I lied to you. We could factor out a 2. So let's go ahead and say, All right, I can factor a 2 out. And that leaves me with 9 plus h squared minus 9 plus h minus, what is that, 72 all over h. And then we can FOIL out in the brackets. The 9 plus h squared is a 9 plus h times 9 plus h. So we will get, I'm going to write this down below, 2 times 81 plus 18h plus h squared. And then I see a minus 9, a minus h. Don't forget to distribute. Number one mistake with these is not distributing minus signs through. Okay, so our goal here is we're hoping to free up an h on the top that we can cancel. And it's looking pretty good so far. What I see in the brackets that I'm really liking is that I have a positive 81, and then I have a negative 9 and a negative 72, which adds up to negative 81. So that actually drops out completely. And the reason I like that is because everything that's left has an h in it. So I see a 2, and then I see an 18h minus h, so 17h, and an h squared. And since everything in there has an h, I can factor it out and say, okay, I've got the 2 out in front, and now I'm going to move an h out in front as well. And what will be left is a 17 plus h. Remember, that's a division. And when we cancel, that was our big goal, try and reduce the fraction, we'll get a 2 times 17 plus h. And again, if you'd like to distribute the 2 through, go for it. I'm not going to mind either way. So that is fully simplified for the purposes of what we're doing here. The fraction won't always cancel out fully. You might have a denominator left over. That doesn't mean you've done anything wrong. Just do your best to reduce these fractions.